Hi there everybody, today we are looking at vectors. So we're going to look at vector notation and we'll look at the different concepts of vectors so you're familiar with it, and of course make sure that you are happy with obviously how to kind of put them together. Alright, so a vector first of all is a quantity which has both magnitude and direction. So that's the kind of purpose of it. It's not about just kind of length of something, it's about saying it goes from somewhere to somewhere and therefore it has a certain length. Alright, so magnitude and direction. Okay, so an arrow gives the direction of the vector, and there are several ways you can write it. Okay, so you'll see sometimes written it like this. All right, so an arrow to A to B, essentially. Sometimes you'll see it written like this, where you've got A, B, and an arrow above it, and again, that's suggesting you're going from A to B because of the arrow above it. Sometimes they give you a letter, sometimes in bold, sometimes it's underlined to represent a vector. So A or underlined A or underscore A. Sometimes they suggest it's a vector like this, like a column vector. So you'll have seen this if you've looked at translation. So you've got 5 right and 2 up. All right, so again, you can see that in terms of obviously how far that goes. It goes 5 right and 2 up just by using the column vector. But if a vector was in the opposite direction, it needs to be written basically the other way around. So B to A would have to be written B to A. If it's the opposite direction of A, then it would have to be minus A. And if it's the opposite direction of the column vector, then it's minus 5, so 5 left and 2 down. All right, so it isn't those ideas, whichever one you go for, or which was required, you need to be familiar with the notation that is there. All right, so if you are adding vectors, okay, there's easier ways of kind of doing this. Is if I wanted to go from A to C, then what I would need to do is I need to add the 2 vectors, all right, because A to C is AB plus BC, all right, so AC is A plus AB plus BC, which is 4, 2 plus 3 minus 1, and that's going to give me 4 plus 3, which is 7, and 2 minus 1, which is going to give me 1, all right. If I have to go here, resultant DF, and very, very carefully look at this, because what I'm going to go from is D to E to F, okay, D to E to F. So this obviously matters in terms of the order I write down, because what I want to do is going to go from D to E and then E to F. But what I've got here is FE. It's the other way around, all right? So I do want to do DE plus EF, but I don't have EF, I have FE. So I need to be basically put minus this, okay? So when I write this out here, I've got DE and then minus essentially FE, all right? Because it's going to be the opposite way around. All right, so that's hence that negative idea. So when I write that one out, I've got 5 minus 3, minus 2 minus 1, and 8 minus 1. And if you look at it kind of relatively straightforwardly, you say 8 across and then 1 down, and that looks reasonable. Okay, so adding subtracting vectors, but just be careful if your vector you've been given is in the opposite direction and how that impacts what you put. Okay, so multiplying a vector by a constant, and again, this is the one that I really want to kind of stress a little bit for those people going for the higher papers. When you're multiplying a vector by a constant, you're multiplying each of the numbers within the brackets by that constant, but actually what you're doing is you're extending the line, you're making the line bigger. All right, okay, so I'm going to talk to you about that. So in general, if you've got a number on the outside and then times it by B and C, then it'd be AB plus AC. So for example, if I've got 4 lots of 7 minus 2, it's going to be 28 minus 8. All right, and then what will happen is that 7 minus 2 is you're extending it by 4 times. All right, so it's going to be 4 times as big. But I'm going to go back a step, because what you will notice is that line and that line, whilst it extends it, they are parallel. All right, and I want to stress this a lot. All right, they are parallel to each other. All right, they're effectively on the same line, but 4 times as long. But like I said, that vector could be anywhere, but because one is a multiple of the other, then it is parallel. All right, and I'm mentioning that quite an awful lot is because I've seen it too many times in exam questions where we're talking about show that something is either parallel to something or not. So I show it's a parallelogram or something to that effect. But if you're trying to show something is a parallel to something, then it's got to be a multiple of it. It's got to be something times it. Okay, so here vectors are parallel if one is a factor of another, and the direction doesn't matter, positive or negative, because if I went in the opposite direction in that way, then it's still parallel, it's just going in the opposite direction. All right, so again, Cannot stress it enough because the amount of times I've seen the exam. So 2, 4 and 6, 2, 12 are parallel because 6, 12 is 3 lots of 2, 4. All right. So that is vectors in a nutshell. All right. So there's this one lesson on vectors. There's another lesson on vectors and problem solving. And together with those two, you need to kind of make sure you're confident with those aspects before you can have a look at exam questions, because you know they are quite popular and sometimes quite a differentiator when it comes to exams. All right, so please go to maths-school.co.uk. Obviously, there's some questions on there to have a go at, but please obviously come back and have a look if you forget. Thanks for listening.